Good morning and welcome to ADMA Unplugged. My name is Andrew Birmingham. I'm the editor of Retargeting. And our guest this morning is the Infer CEO, Vik Singh. Good morning, Vik, or good afternoon.
Hi, thanks for having me.
Thanks very much. I think you've been called one of the most promising innovators under the age of 35 by the MIT Technology Review. Can you tell us a bit about yourself?
Sure. So before starting Infer, I was previously working at Microsoft, Google, Yahoo, mostly working on kind of data science products and trying to come up with new techniques and features for improving things like web search ranking, to improving the click-through rates on the Yahoo homepage, and a variety of other projects. And before that, I was at Berkeley and I studied computer science there. And now taking what we learned at Google and trying to apply it to the enterprise space.
Fair enough. Now, the whole data science space and data analytics space has really taken off in recent years. Very interested in your observations on the data world right now and what you see as some of the key trends that are happening.
Yeah, so I think the big trend that we're seeing is there's a big kind of transition and acceptance of verticalized based applications built around data. So I think it kind of started, there's a lot of energy around endorsing and building your own products and applications on top of BI tools and infrastructure and analytics that you would roll on your own. So which has its merits. When you're a company like Google, you have very customized needs and you have to have certain types of you have certain requirements and certain amount of scale that you need to achieve that that requires you to customize. But it also requires you to build a lot of in-house expertise. You have to hire, computer scientists and statisticians and folks who know how to apply these tools to building the models and building the products and applications that you want. But for the rest of us, all the other companies who don't necessarily have that talent base or that or can't really justify building that kind of infrastructure in-house, they can now go and accept vertical applications that solve specific problems. For example, for us, we solve specific problems in the sales and marketing space. There's a variety of other solutions that solve problems in the recruiting space or IT, and they're using machine learning. They're using fancy kind of techniques in the back of the scenes. But you don't need to know that as someone who buys a product. You just need to know what your objective is, and then you can buy these services as SaaS services and run with it. So it means that now folks can get the benefits of data science without having to have PhDs in statistics in their company.
Okay, well, let's explore that thing a little bit. At the moment, companies are doing all kinds of things with data to try and generate large volumes of leads. But from your perspective, do you think they're doing it right?
I think I think companies have really invested in a variety of different types of solutions and strategies for growing their lead base. And marketing has become far more data-driven, and there's far more channels that they can work with now than they could have worked with before. Now you have things like AdWords, you have retargeting, you have Twitter social advertising. There's so many different ways you can go and get leads, and you can put money into those channels and acquire more leads. So I think those techniques are very sound. I think the trickiness is how do you actually process those leads? Now that you're working with leads across different types of channels, the behaviors and the types of leads that you're getting from each channel is very different. So when you pass them to your salespeople, they need to be aware of that, or you need to prioritize them differently. And that's kind of the reason why we exist, is to help kind of filter the noise and make sense out of those leads so that you know what to do with them and where you should apply your energy to.
Okay. Now you've experienced a lot of work with companies like Zendesk and Tableau and New Relic. And one of the things I guess about your organisation is that you're using mixed client data, you install the web, you use a lot of third-party data. What's the balance of the value of those various sources? What makes your approach different?
Yeah, so when you look at kind of traditionally how these companies were getting data about their leads, it was based on the data that the lead was providing to them on their website. So if you go to Zendesk and you sign up for a trial, you're providing your name, you're providing your email address, and they use that information to determine who you are. And the nice thing about the internet is there's a lot more data about who these people are and what those companies are doing. And so we go and crawl that information so we know what the company size is, are they hiring people. We try to get as many signals as we can so you know kind of whether they have the intention to buy your product. And those signals end up being very important. The thing that's interesting about our approach is we're machine learning a model for every single customer. So it's personalized to each business. So the value and the sources and the signals can vary. So for one company, maybe some of the signals that we're collecting around, who's hiring and how many people are they hiring and in what departments, that might be a very important signal for one company. But for another company, maybe that's not that important of a signal. So, but I would say overall, though, that external data, that data that they're not collecting, that we're collecting from the web, ends up being very valuable and important in the model, and plays a pretty big weight in the model in terms of how well it can surface the right deals to go after.
Okay. And just what kind of analytics techniques do you find to be most useful? Perhaps you can give us some examples of work that you've done.
So I think for us, what's been most useful, has been a variety of different types of machine learning techniques, and so we invest and we experiment with a variety of those types of techniques, such as gradient-based decision trees, logistic regression, and even naive Bayes. We've played with all these different algorithms, and I think which one you use depends a lot on the use case and what you're shooting for. Are you shooting for more explainability? Are you shooting for you're trying to optimize for overfitting and dealing with those issues? And the other stuff that's useful for us is techniques and algorithms for doing better feature selection. Also, better algorithms, techniques for being able to handle sparsity, and because data is not clean, and we're all challenged with dirty data, and you have a lot of missing data. And so there's a variety of different techniques for dealing with that, which depend on kind of what the algorithm you're using is. The other thing we found useful, and this is not even an algorithm or a technique, is just being very analytical to start. So you hire people who are very inquisitive, you don't want to necessarily stop at, hey, I ran it through an algorithm, here's the result, I'm going to give it to a customer, but really wants to understand what's going on. And that usually results in specific algorithms or techniques that you'll come up with to help you do better and understand your models better.
Fantastic. Now, I understand you're a big fan of mixed martial arts.
Yeah.
You've actually applied some of your methods and some of your learnings to the statistics in that industry. It'd be really interesting to get some insight from that. To really get a sense, I guess, from beginning to end of the project that you ran, some of the things that you learned from that.
Yeah, so a few years back, I crawled. I built a crawler to go crawl all the fight data from SureDog.com and ran our algorithms over it to see what it can pick up. And specifically, I was interested in, can you predict the winner of a fight before the fight even happens? And how accurate is it? And what I found was it's actually pretty accurate. There's a lot of science in fighting, and if you look at how technical the sport has become, there's remnants you can learn from previous fights that can help you understand how they'll perform in the next fight. And so there's a bunch of the big thing about when you build models is what features you come up with, and a big benefit I had was I was very into the sport. So I can come up with signals that actually made sense. So things like, hey, is this fighter someone who's more into jiu-jitsu? Are they more into Muay Thai? What's their background? What camp do they come from? Where do they train? To basic stuff that other folks could probably discern, things like, what's their age? How many fights have they had? Are they on a winning streak or a losing streak? How much momentum do they have? How good were the fighters that they beat before? So I built up a bunch of these features, and then we built a model over it, and the model did quite well. And I think the key thing there is it wasn't so much the algorithm that was being applied; it was more the data preparation. Crawling the data and piecing it together is non-trivial. Jim Gray, who's someone I worked with at Microsoft Research, always said, it's 99% perspiration, especially in data science. You're doing a lot of low-level kind of not very sexy work to kind of get everything together, and then that 1% is actually the fun part. But it's important to kind of get the results you want. So I think coming up with the features and determining kind of what features made sense was probably the most important thing. But I think in order to do that, you have to really have an understanding of the sport.
Yeah. Let's talk a bit about the 99% perspiration. Can you tell us a bit about some of the techniques that you used and some of the tools that you used in the project?
Yeah, so I built a basic crawler in Python, nothing fancy, and it was customized for SureDog.com to pull the data. And then in Python, I also pieced up the data so that we can assemble the training data that we wanted. And then I used actually a fairly basic machine learning kind of open source library, Orange, to build a random forest model from that data. Which there are probably other models that can work well, but I just ended up going with that one because it typically does well out of the box with very little tuning, and then those are the results I presented. And then there's another thing that I developed, which was basically a segment finder. So basically, it's looking through all the features and it's trying to find interesting kind of segments or pockets. So things like fighters from Japan who are 32 and older, they actually lose more often, and here's why, and how much data there is behind that. And so that was kind of the second part, but that was more of a brute force, kind of try all combinations and see what you find.
So after you've built the model and you've got it working, you watch your fights, does it sort of take away from the enjoyment of watching them? You kind of know the resulting events, or you think you know the resulting events?
Yeah. I mean, the thing... fights are interesting, irregardless of the result. There's just a lot of stuff that goes on. What the model doesn't predict is how long the fight will take, whether they'll go to the ground or whether it'll be a knockout or whether it'll be a TKO or any of those things. And maybe you can build models that can do that, but the more granular you get with your prediction, the harder it is to build those models. And so fights are always interesting no matter what. And the thing is, the model's accurate, but it's not always accurate. There's always a chance that a fighter wins that you didn't predict. But then the thing is, the model will learn from that and get better. So it's just kind of one of those things. It's a cycle.
Let's talk a little bit about the wider applications. What were the things that the learnings from that can apply to other industries, or that other people listening to this can apply to their own approach? And can it be used, this approach is going to be used by marketers to better predict the way their customers will behave in the future?
Yes, definitely. In fact, we're kind of a case in point for that. At our company, we are, applying the same techniques. We're using random forest models and other types of models, except we're not running it over MMA, UFC data. We're running it over sales data. And we're instead of trying to predict whether fighters are going to win or not, we're trying to predict whether certain customers will win or not, and whether you can close a deal with them or not. There's a lot of parallels, and the techniques are very amenable to either problem. And I think you're going to see more and more of this. There's already kind of smart solutions, predictive solutions being built like this for recruiting applications, for finance, for forecasting, marketing, sales is where we're at. We're starting to see this stuff even with network, like IT networking, trying to predict congestion, trying to predict whether things will fail. So I think we're already kind of entering that age, and it's just going to become more and more prominent, and there's going to be more and more companies providing these offerings so that everyone can benefit from this without having to, hire data scientists on their own and build this stuff in-house.
Yeah. And do you think there's ever a risk that marketers in particular who don't come from, say, a data background, that they become too confident or too beholden in the data models? Is there a risk that they might have expectations beyond what the models actually deliver? And what should they be learning as they go through and begin these techniques?
The key thing is there's a couple of things that we do when we build our models. One is we can't position these models as kind of like fairy dust that you sprinkle into your environment and you get value out of. It has to be seen as a tool that the customer or the champion understands, and it's a part of their kind of their toolkit to apply and use. And so in order to do that, they have to understand it. They have to understand what it means and how to apply it. And the other thing is it's not so much the data and the science that's like really critical to building advanced models. It's also how you end up using it. So for us, we very much blend art and science. So the art of kind of, you know, our champions who are thinking about the use cases, how they want to apply it and everything else, there might be certain scenarios where applying the model there makes sense or maybe it doesn't make sense. Giving them control so that they can dial it up and down is really important. And also being a part of that feedback loop. So as they apply it and run it, maybe what happens is the behavior of what they see after they run the model is different than what we predicted because of changes in their process or because the model's just returning kind of the same results over and over. So there's solutions that we've come up with around that, but it very much requires working with them and thinking of our solution as a tool for them for doing their job better versus, hey, we're trying to come in and replace things and automate you.
Well, it's interesting. I guess an interesting example that I get from your mixed martial arts example. I understand that when the results got known and the reputation got out there, that you were actually approached by professional gamblers asking you to help them with their bet. What was your response to that, and what did you tell them?
Yeah, I probably get about a dozen emails a week today. I mean, still this week, like, you know, probably every week, even now, from folks who want to get access to the code and they want to run it and they want to make money off of it. And you know, I just haven't maintained it. So it was a little while ago since I built it. So I wouldn't be making bets on it unless I took a closer look at it and retrained it with the latest data. But you know, it definitely, I think, encourage people to be more data driven about MMA. And you know, if you look at baseball, Moneyball, you look at all these different sports, you know, data has become a very important part of their strategy in terms of what players they invest in or how they approach games and their strategies. I think the same thing should apply in mixed martial arts. I don't think it's really fully happened yet, but it will. And it was kind of nice to be able to show that to people that it's possible and it's very doable and it makes sense. I think it could make even sense to the actual fighting organizations like UFC when they're thinking about what fighters to pair against each other and trying to just come up with fights that are going to be good fights and are fair matchups. You can use science and data to do that as opposed to just marketing and like looking at the fighter's reputation. You can try to look a little bit deeper than that. So, because at the end of the day, people want to see good fights, and so I think there's a lot of ways you could apply something like this. But you know, the company Infer is keeping me pretty busy, so I'm not able to do too much with that.
Now, I understand you've also applied some of these techniques to the stock market. Could you talk a bit about that and talk about the you know, some of the issues that arise when you try and apply these approaches to different stocks?
Yeah, so what I did in that analysis of the MMA fights is I compared it against how the stock market did at the same period of time. I think my model for MMA fights was like a 13% return in a pretty short period of time, and then in the same period of time for the stock market, it was like a negative return. So it actually returned better results than in the stock market. So that was a pretty interesting result. In terms of applying predictive technologies to the stock market, you know, I think there's a bunch of companies and hedge funds that are certainly doing this, and probably much better than I can do because they just have a large team. They have the ability. They have lots of data. You have to buy a lot of data to be able to do it right. Very granular levels of data. But the fact that the MMA fights in a very small valuation, caveated, did better than the stock market is kind of interesting. So the result was kind of like, hey, you're better off betting on MMA fights than you are investing your money in the stock market. But it was more of a comical result that would need more back testing to prove it. But I think there's something there.
Now, we do have time for a couple of questions from the audience. In fact, we've got one now from Ian. So he's asking, Vik, can you give an example of how you approach remarketing with the techniques you've got?
I'm not sure if I understand that. So how we approach remarketing?
Okay, so Ian, if you're watching, perhaps you can give us a little bit more detail on your question. So we'll just go and ask him now. And just while we're waiting, were you tempted at all to take your techniques that you applied to mixed martial arts and actually put a few bets on yourself? And likewise with the stock market.
I didn't put. I haven't made any bets, actual bets in MMA, mostly just because of time. But the results showed you can make some good money. So I did was I built a model, and then I looked at fights that took place after I built the model, and then I looked at the betting lines, and then I basically tried to see how much money I would have made if I betted on those fights, and it ended up being a very good amount of money and a good return. So, but I didn't actually put real money on it, so I can't say.
Andy's come back and what he's saying is remarketing is when a customer leaves your site without making a purchase or a click. And then presumably what are the techniques to then follow that person afterwards?
Okay. So we haven't approached that specific problem, although there are a variety of ways where our solution could be applied to that. For example, when we look at like if you look at, for example, retargeting, which is one way to kind of go after your users who come and click and get clicking on your website, and then they go to other websites, and you want to follow them, you show ads to them. One idea is that you can use the Infer score, which represents the potential whether a potential customer will buy your product. You can use that as a way to influence how much you spend and how much ads you want to put in front of a particular person, because not every person who comes to your website that you go and retarget to is going to be of equal value, right? So if a student comes by to our website and is just doing some academic research, we don't necessarily want to spend millions of dollars putting ads in front of them. We'd rather put those millions of dollars in front of someone who comes from a top company that we want to close. So this has been something that we've actually been exploring with some companies. So we think there's a lot of ways where you can apply something like this to even kind of the kind of these types of problems.
Okay. Well, thanks very much for your time today. Very interesting session. So I appreciate your time and all the best in the future with the company.
No, thank you very much. Really enjoyed it.